So I've been finding that I'm using the propane torch and heating the ends up pretty good, letting the enamel burn a bit, and then basically hitting it with the wire wheel carefully, just kind of supporting it with my fingers down below and letting the wire wheel clean the end off. That's not too bad. Seems to be doing pretty good. I do realize you got to be careful how you anneal the copper, so I'm letting it cool on its own, which conducts the heat back through the windings. Down here it cools really fast, so that seems to be working. Stay tuned. I think I've got this figured out, so I will post once I have them cleaned up and tested. So it seems I think I have this figured out. Basically, once I remove this paralleling strand, which is basically just probably to keep the sides balanced, to stop any unwanted unbalance, if you want to call it that. It's kind of a guess of mine anyway. I split the two sides, and under each of these green insulated covers basically was two sets of windings, each 15 strands. So on each side, for instance, I would have like a B1 and a B2. And what that means is black 1 and black 2. So I labeled this one here. This is my black 1. And then I have a black 2 right here. You can just see the black under there. Those were originally connected together coming out of the motor. And then there was two whites, which are down here. You can see here's one white. Sorry, there's one white come from that side, one white come from that side. So I got 1 and 2. And then I got two reds or orange, whatever color they are. Sorry, I'm slightly colorblind. This one would be orange 1 or red 1, and that's red 2. So basically what it is, I label them black 1, black 2, all the way around. I have on each side in the groups, I have a black 1 and a black 2, a white 1 and a white 2, a red 1 and a red 2, and on both sides. So what I have to do is connect all the 1s together for a Y termination and all the 2s together for a separate isolated Y termination. What I'll probably do is use a couple of these barrel lugs on each side and crimp all the 2s on one side and then run a wire. It's kind of like this one that was multi-strand from one side to the other. I'll run something like this. Maybe I'll cut it in half. It'll be long enough. I'll figure it out. But I'll hook all the 2s together up on one side, put this barrel on with an extra wire that comes across, hook all the 2s up on this side and crimp them. That would be one Y connection for the one for number 2 side of the stator, which would be for this black wire, for this white wire, and for this red wire, and that would be to one controller. Then all the 1s get connected together on each side with a paralleling strand, and that would be this black wire, black 1, this white wire, white 1, and this red wire, white, red 1. Now, I would love to, I know somebody's going to ask the question, why don't I just bundle them together, all the 2s, all 6 2s together? I would love to, but I don't think like this R1 can reach across to hook up to W1 over here, if you see it, white 1. So R1 and white 1 aren't going to be long enough, so I think that's kind of why they did it that way. We want to keep everything as short as possible and put as minimal wire in there as possible, but definitely think this is solved now. So it's a Y-wound motor, and it does let me split the phases like I was hoping, and this will let me get that wired so I can get this part done and get it potted, which will be the next stage, and then back together again. A little bit warm, but I can still work with it. So normally I support it with one hand, but simply going like this. Cleans them up pretty good. I'll just set the phone down so I can get a little better of a job on that. Perfect. Let's see how that looks much better. Hopefully that focuses. It's cleaned up pretty good. Get that to focus there a bit. Slow camera, but not too bad. Okay, I'm on my last on the home stretch, I guess you could say. I got 2 sides here, 1 and 2. Basically, this is like, for instance, this black 1, that's black 2. And then I've paralleled with the original. It's 15 strands. I didn't measure what gauge it is, but 15 strands of enamel wire running from one Y side to the other Y side, which were already connected, but I think it's just a balancing wire, like I said. So now basically what I'll have is on number 2, if I take a multimeter and I go here to say, I'm just gonna get a probe to stay in there, then I'll bring the multimeter over here to number 2, say red 2, we'll have continuity. If I go to white 2, which should be this one, we'll have continuity. There it is. And then if I go to black 2, just got to get back on that Y termination, black 2, we'll have continuity. Of course, my measurements aren't perfect doing it with one hand, trying to hold the phone and everything, but this should be black 2 right there. And so now if I go to black 1, it should be isolated. And that's black 1. If I go to red 1, it's isolated. Go back to red 2, it's conductive. So if I switch this over to number 1, which is Y termination 1 on this side, which is what I've masked off with masking tape, I'll go here and I'll have continuity. This is black 1. It's a little tricky because I haven't put crimps on these other parts, so I have to finish the last little bit here. There we are. So there's my continuity. So now if I switch to black 2, there's no continuity. Go back to to white 1. Yeah, white 1, that's continuity. Go to white 2, no continuity. Go to red 1, got, there we are. Just trying to touch it. The ends of the wires have been, are all that's clean. So I gotta get the probe to rest on the ends of the wires for continuity there. And there we go, we got continuity there. And red 1, no continuity, or 2, no continuity. So essentially, this is 2 sides. There's a stator on this side and a stator on this side. They're electrically isolated from each other now. And I'll have 6 wires coming out that are electrically isolated. 2 groups. There'll be I'll call it phase ABC1 and ABC2. You could also do UVW1, UVW2. Either way, I'll number them 1 and 2. That's all I need to make sure I have is a 1 on this one, a 2 on this one, a 1 on this one, a 2 on this one, 1 on this one, a 2 on this one. And then on the outside, actually I should have ABC, because it'll be black. They'll be in sync with each other. Because if we decide to run a controller with, we have 2 options on this. I've dealt with sending motor position sensor information from one controller to another before. That's not super fun. I did it with Zero Motors with a UVW Hall sensor output for the dual motor controller setup, 2 size 4s on a 75/7 split phase that I did with that. And then I've actually helped somebody else do a bigger setup with dual size 6s, and we used the sine cosine sensor, and I made an isolated adapter board that run an isolated sine cosine signal to the second controller, because even if you have a ground like this far away from one controller to the other, it'll have like a volt or 2 of bounce in it sometimes, and that'll be enough for the sine cosine sensor to get all unhappy and throw faults and stuff. So by isolating it, you don't have to worry about that. That becomes a huge issue with this because we're running a resolver for the motor position sensor. The resolver is very complicated, and I don't know if there's an easy way. I don't think I know there is not an easy way to run resolver signal from one controller to the other. So we might run a dummy controller where it doesn't do anything other, like it might not even have a brain board on the second controller. We might just run IGBT gate signals to the gate drivers from one controller right over to the other. That's a little worrisome. It will have fault detection with DSAT on the second controller, but you would be losing your current sensors and a bunch of stuff if you do it that way. So we're still coming to conclusion on how we want to achieve that, but this part will be done. The cool thing is I'll be able to just parallel the wires on the outside to run one controller to prove the motor is good. And one other benefit to point out of this, it's not just that you can feed more power because you'll have two controllers. You are going to have a limit to the what the windings can actually take at some point. In fact, it probably won't even be what I've done so far, but this motor will be rated for more power. Don't let me misconstrue that, but basically it'll be a burst rating. We're talking 5, 6, 7, 8, 9 seconds, something like that, quarter mile kind of stuff. And it'll be potted to help pull heat out better, so that'll be a benefit. But there'll be big benefits because you'll be splitting two stator sections apart, which actually reduces the increases the inductance by 2x. So 2 inductors in parallel cuts your inductance in half. Kind of works like a resistor. So we measure typically around 169 microhenries of inductance phase to phase on this motor. That is at 100 amps. And I found that running higher amperage, like 800 amps, I'm usually putting in a number around 69 microhenries. And it seems to run pretty good around 68, 69, 65 in that ballpark. Now we can double those numbers. That'll mean the current rise time, it'll be a lot easier for the controller to control the current. Now we're going to push it further into saturation, but that's okay because we're going to have more inductance to play with. Even as we approach saturation, as the inductance falls off the face of the earth, we'll still have more. We'll have double of whatever it would be. So if we're running 800 amps on 2 different controllers into the motor with basically instead of, so it'd be 1600 amps total. Well, we might want to set a controller at 30 microhenries of inductance if we're only running one controller at 1600 amps. Yeah. So if we run 2 controllers, each feeding half the stator at 800 amps each, then we will probably have double inductance. So say at 1600 amps is just a guess, 30 microhenries of inductance, then it would probably be roughly 60 microhenries of inductance for each controller to deal with at 800 amps. So it's going to be a lot better that way. Winding resistance will be high. I don't think that's an issue. Like I said, I'm going to pot this. It's going to pull the heat out a lot better. It's going to help, but it's definitely exciting stuff. I'm getting really close now. I'm going to try and figure out my lugs for my extension wires on the 6 outputs, and then I'm going to start on the potting process.
Well, it's midnight Sunday. At midnight, just finished crimping my last 2-aught wire coming out of my leaf motor, and I'll have a 6-phase leaf motor. It's been a long day, lots of work this weekend getting this organized, getting this done as far as I could. Basically, if I take any of the ones with a 2 on them, they have continuity to. So I have a W2 here and an R2 here. If I connect an altimeter on one and the other here, let's see if I can do this with I have continuity. If I go to a 1, like right there, go to that, I have no continuity. So basically I have red 2, red 1, white 1, white 2, and then black 1, black 2. So now I can run dual controllers with the same motor position signal, and the this thing should be a ripper. Next step is for potting. First I gotta get some twine or whatever and tie all my windings back down. And then these 6 wires are gonna be pretty tight coming out of this cover. I might have to make a modification there, but that's for another day.